Hello, so today I'll show you around the bridge design workflow using the Autodesk AEC Collection. So this is how a typical bridge design might look like within the AEC Collection. As you can see, it is very much an InfraWorks-centric workflow. So during the conceptual stage, both your road designer and your bridge designer can work inside InfraWorks to identify the best routes and produce an initial bridge design through various optioneering iterations. In Civil 3D, this is where the road designer can then start to solidify the road design. They can start to produce necessary road documentation from here as well. Of course, at any time, the model can be sent back to InfraWorks, and this could be an iterative process. Within Revit, the bridge designer can then start producing, your bridge documentation, including your drawings, your schedule, bill of materials for the preliminary and the final design. Optionally, Inventor can also be used where there is a requirement for custom bridge parts. This can be developed in Inventor, and you can use this to expand the bridge assemblies. And also at a later stage, the bridge engineer can push to structural bridge design to perform any necessary calculations to fully verify the bridge design. Now, I understand there's a lot of moving parts to this workflow that I'm showing you right now. Hopefully you don't get too intimidated by it. But for today, our main focus would be on the InfraWorks side of things. We'll also try to touch on the other sections to give you an overview of how it all comes together. Now, what we're going to do is we're going to jump into InfraWorks itself to show you a live demonstration. So this is the InfraWorks solution. To start a new project, you have two options. You can either click New and begin a project from scratch. But a suggested option will be to start using Model Builder to create a new project. What this will allow you to do is select a project location. So if you, for instance, say Brisbane, you can either draw a rectangle or a polygon of your project site, give it a name, a coordinate system, and download it. Or what you can do is you can also import a shapefile polygon of your project area. What this would do is it would download an OpenStreetMap data set of your vicinity. That way, you wouldn't really need to start your project from scratch. So in the interest of time, I have pre-downloaded the area that we were looking at just a while ago. And I'll show you what the dataset might look like. So in here, you'll notice that we have the Brisbane project area. We have your buildings dataset, which is actually quite comprehensive. If you click on things, you'll see that it even has a name, the height, and other information in there as well. You'll also get data sets such as the road network, some elevation, and even some water features in there. So once you've downloaded your project area, the next thing that you'd probably want to do is just make sure that you have the correct settings for your project. So things like the coordinate system, the design standards, and just make sure that you're actually driving on the right side of the road as well. So once you're happy with it, just hit OK. The next thing that you'd want to do is add in additional content for your dataset if you have any. Of course, this supplementary information or the out-of-the-box data that comes from OpenStreetMap would be a good place to start. But If you want to have more accurate data set that you can base your designs from, you can add supplementary information from your corporate GIS. You can also download from free government websites. Like here in Australia, we have the Geoscience Australia website. We also have the Elvis website where you can download free digital elevation models available for everyone to use. Now, these are just some of the available data sets that you can bring in on the solution. You have Revit, point cloud data, you have DWG files as well, and others. Now, what we're going to do is we're going to jump to our project where we would start creating our bridge. So for our case, that is the lane end crossing. So here is an example of a bridge that we will try to create today. As you can see, there's a fair amount of detail that you can achieve in here. So I'm just going to go to the project area where we will start to build our bridge. So we just want to lay it around here. Now, to do that, the first thing that you want to do is to create a road. For you to achieve that, just hit create, click component road, make sure that you have the right standards selected in there. That's, of course, achieved through the project settings that I was showing you a while ago. And then you can start drawing your road in here. So for now, I'm just going to roughly sketch in here, like so. So at the moment, as you can see, I have a 4-lane road in there, which I think for this one is a bit of an overkill. So what we're going to do is we're going to select that, and we're going to replace that road assembly to something a bit simpler. So for now, maybe 2. And let's hit that and make sure that we actually apply it to the whole strip. If we hit enter, that should update our design. All right, I'm quite happy with where that is at the moment. But as you can notice, what that's done is it's actually created an intersection on a very busy street, which is something that we don't really want, right? What we want to do is to create a bridge in here so that we don't disrupt the traffic. So for us to do that, we're just going to raise that road a little bit by clicking vertical view or profile view and controlling the heights from here. So I'm just gonna roughly raise that to be above the existing ground, like so. So when I hit enter, that should reflect on our drawing as such. So I'm quite happy with how that looks at the moment. So we're gonna leave it as is. So now we don't really have a bridge just yet. Even though it's suspended in the air, that's not a bridge just yet. It's still a road. So what we're going to do is we're going to convert this section of the road to a bridge. To do that, just select the road, click Add Structure, Bridge. Now from here, InfraWorks will give you various options on how you can add this bridge, right? You can manually enter the chain age, length, or end chain age in there, or you can just roughly draw on the map as well. For my case, I'm just gonna click a start and an end from the map. Hit enter, and that should have created a bridge. So it's just roughly given it a name called Bridge 3, which you can change for now. Like maybe you want to call it Magnolia Bridge. You can also see here that we have various attributes in here that we can control for our bridge. So the moment that we created the bridge, InfraWorks have added in the necessary components in there. So we have our abutments, our piers, our girders in there available for us. It's also added in like a default number of piers. So for the length that I have, InfraWorks has added in just one pier, but obviously we can change that as well. Another thing that you can control here is the design standard. So inside InfraWorks, there are various design standards available for us to use. For us, for instance, here in Australia, the Australian standard is the one that we normally use. So with our bridge, the next thing that you want to do is try and control the various components in there and make sure that it suits your design. So for instance, in here, if I click on the abutment, I can change things like maybe the offset or the skew. And that should reflect accordingly. Maybe I can do the same thing for my piers as well. If I want to change the skew in here, hit enter, and that's shifted as well. Maybe not the right angle for this one, but that's something that we can control a bit later too. Now for our girders, if you select that, you'll see that we have various options in there as well as to how we can select the component girder. For instance, for here in Australia, we have various predefined girders that we can select in here to use. Can also control both internal and external girders. Can also control the number of girders. So if I, for instance, change this to 5 and hit enter, that should reflect on my design in here once that loads up. Now, once I'm happy with that, I just maybe want to apply that to the other girder groups as well. All I have to do here is click apply all girder groups, and that should reflect accordingly. Now, for my pier and foundation here, I can just select that. Maybe I want to, tilt that a bit. I can manually do so. For my pier, if you, for instance, want to use a predefined or a customized object, it's not just for the pier, but for the other components in here as well. What you can do is use Inventor to create your component and bring that in here as an object. So I'll show you how you can do that. For this demonstration, we'll skip the Inventor part. I'll just show you how you can bring a pre-created Inventor part here inside InfraWorks. So to do that, all you have to do is select Style Palette. You can go to the location where you want to add that palette to. So for our case, it would be under Bridge. It will be a pier, and you can add an object in here. I'm just going to browse to where I have saved that. So for my case, I put it in under my Inventor folder, and I called it Tester. I'm just going to give this model a name as well. I'll call this Demo Pier. Hit enter, and that should be now available as an option for me to select from my pier components. So I'm gonna exit from this style palette and actually go to this pier and replace the type. So if we look for the demo pier, it's this one right here. You can just select that, and now it's available for us to use. Now this foundation, I know it's like a bit high up in the air. So what we can do is we can pull this down a bit. Maybe we can give this, a -3 height above the ground. And that should pull it down to where we need it. So at this stage, I'm quite happy with how that looks like. Another option that we can do here is instead of selecting all these options and doing the changes from InfraWorks, what you might also want to do is perhaps do the changes in a spreadsheet format. So what you can do is send this to a spreadsheet. So just right click, send to spreadsheet, create new. Just going to save this on my desktop. And perform all the necessary changes from here. So you have all your bridge components. You can control the values from here. Then once you're happy with it, save it and update it back into your InfraWorks. So once you click update existing, that would just read off the export that you have created and just apply all those changes that you've done. Now, if we look at the analysis section of things, there are a few things that you can perform in here. The simplest one being producing quantities. So with your bridge design, what we can perform here is just a quick calculation of the quantities that we have for our structure. So at the moment, you can see that there's a lot of concrete in there and not much steel really. So let's just do an example. If in here, if I, for instance, change this girder to a steel plate, and hit enter, you will see my steel quantities updating as such. Now, if I apply this to the other girder groups, you'll see those values update accordingly as well. Now, additional things that you can perform here is you can perform line girder analysis and even refined analysis. Okay, so for this one, we actually do have a result. So if we open the output folder, show you the report for this. So this one's using the grillage method with the ASHTO as its design code. And this actually runs for 66 pages for this bridge. So it actually produces very detailed analysis of each options or each sections of your bridge. As such. Additionally, you also have the option to continue this analysis in your structural bridge design software. So once you hit that, it will try and open up your Autodesk structural bridge design solution and can perform your necessary calculations from here. Let me just see if I can show you the girder analysis. Let's see if probably in my project area, I have this available. So I do have this available. Urban output folder, report. It produces a report for each of those girder. Now, what you might also want to do is bring this bridge into Revit. And to do that, you can just hit Publish Civil Structure. You can create a new file and hit Create. Now, you'll see here that for you to do this, it requires for your project to have a projected coordinate system. So that just makes sure that your bridge is actually displaying in the right location in your Revit. So in the interest of time, we're going to skip that. And I'm just going to show you how that might look like once you start bringing it inside Revit. So to open that in Revit, just have to create a new project. Go to Add-ins. Just make sure that you have the InfraWorks add-in installed for your Revit. That would enable the Import Civil Structures button in here. It's just asking me to save it first, which I'll do. So I'm just going to put it in my desktop for now. Save. And now it's asking me to import my civil structure. So I'm just going to hit import on this one that I have pre-created. And go to my 3D view. Might be this one. Let's try this one. I think this one looks a bit better. So you'll see there, have my bridge. Should be able to navigate this a bit smoother. Where is my, there you go. So it's created the whole road for me, which, what you can just do is just turn off those other components that you don't necessarily need. So for instance, if I select this one, it's gonna hide it in view category. So that's the road. Just gonna hide this deck in view as well. So now we're just seeing the girders in there, our pier and our foundation. All right, so hopefully that is useful for you, and hopefully you managed to learn a few things about bridge design using Autodesk AEC Collection. Thank you.